two oxygen molecules. And that's the starting point. Remember the state function. We're always trying to figure out the starting point. Okay? And then we're trying to figure out the end point. The end point is you end up with carbon dioxide and water. Okay? So what's the energy requirement for each of the steps there? Well, we can add them together. And this is something that you can find. Carbon reacting with 2 moles of hydrogen gas. Each mole of carbon reacting with 2 moles of hydrogen gas to form methane. That's the standard formation of molar enthalpy of standard molar enthalpy of formation for methane. This number is given. You can find this table. And if I go back a couple of slides here, methane. So we have methane, okay, negative 74.6. Okay, so you find the information. You find the information from the table there. This particular reaction, negative 74.6. Okay, and then the second reaction, carbon reacting with oxygen, giving you carbon dioxide. Okay, and that molar enthalpy of formation, you use the same table. You find that information. And then hydrogen reacting with water. Now, in this case, and this is where you would expect to see a fraction in a balanced reaction equation, because we're talking about molar enthalpy of formation, 1 mole of water. Now, in order to form 1 mole of water, you only need half mole of oxygen with 1 mole of hydrogen gas. Okay, so we could put a 1/2 in front of oxygen there, just to give you H2O. The molar enthalpy of formation for water is negative 241.8 kilojoules per mole. Okay, now with these 3 equations, we're ready to figure out the overall entropy for the burning, for the combustion of the methane gas here. Now the thing here is that we're doing addition here. If you add everything together, you will see, well, carbon, carbon, hydrogen, hydrogen, oxygen, oxygen. You have carbon, hydrogen, oxygen on the left side. Well, in the overall reaction, you have methane and oxygen on the left side. So you got to reverse the first reaction. You got to put methane on the left side of the equation. Okay, so we will have to reverse the first reaction before we add everything together. Okay, so in this case, methane going from methane to graphite and hydrogen gas. The overall enthalpy of formation, well, the overall enthalpy for that reaction would be going from negative 74.6. That process, well, the forward-going reaction is the exothermic reaction with this quantity. Reverse that reaction, you change the sign of this number. The quantity stays the same. Energy is conserved before and after reaction. If one reaction going from left to right releases this much energy, when you reverse the direction, well, the energy stays the same. You just change the sign. So in this case, we have methane going into carbon and hydrogen gas. The enthalpy of that reaction is positive 74.6. I said, why do you reverse that reaction? Well, if you reverse that reaction and keeping the other 2 reactions the same, when you add all the 3 reactions together, you will see graphite will cancel out. Carbon cancels out. Okay? And then hydrogen also cancels out. What's left is methane plus 2 O2. You get O2 here and O2 here. So on the left side, you get 2 O2s. And there's only just 1 CH4. So what you end up with is methane plus 2 oxygen equals to, well, gives you carbon dioxide and 2 moles of water. That is the overall reaction. That is what we're asking you to figure out. So by adding things together, and sometimes you may need to reverse the reaction. Now, how do you determine whether you need to reverse a particular reaction? You look at the overall process. Overall process says methane needs to be on the left side of the equation. The given information, methane is on the right side of the, well, flip that reaction. Okay, so that's how you determine what you need to do with the reaction given to you, whether you flip it or use it as it is. It only depends on who's on which side. And then once you identify who's on which side, all you need to do is to manipulate the reaction equations there, either flip in them or use as it is given there. all you need to do is now adding these three numbers together. When you add everything together on the matter aspect of the chemical reaction, you get the overall reaction. On the energy aspect of the chemical reaction, you just add all the numbers together. Negative 802.5 kilojoules of net energy. Okay. So calculation involved in this chapter really is a fairly simple addition and subtraction, but you have to keep a very clear mind about who's on which side. And once you determine that, you can punch in the number in the calculator. Without a calculator, you should be able to do those calculations. There are simple addition and subtraction. Okay, so you have several exercise problems in your homework, as well as the third quiz, and we're asking you to do the calculations there. So the practice there is that you have, for some of the questions there, you have to look at the overall reaction, and you have to decide how you're going to flip, which equation you're going to flip, how you're going to flip it. And then when you flip the direction of the equation, the energy changes in terms of the energy is the sign here. Okay, so going from graphite, hydrogen gas to methane, it's an exothermic process. It's negative 74.6 kilojoules. If you reverse the process, the amount of energy stays the same. You just change that number to a positive number. Yeah. So again, chapter 6, and that's going to be the material on the third exam, and this is something you probably after tomorrow's exam you have a little bit more time to review about this topic there. And I do urge you to take the time to read the textbook and make sure you finish all the questions assigned in chapter 6. And that belongs to homework number 2. Okay. And I'm looking at the homework assignments in chapter 2, the homework number 2. Homework number 2 covers everything all the way through chapter 8. And I think I may be able to finish chapter 8 by Wednesday. And I'll see what happens on Wednesday, and maybe I'll see what happens today when we finish the lecture today. And we'll decide if we're going to push the due date of the homework to Monday after, instead of this coming Thursday. We may need to push it back to Monday after. And that way you will have maybe the weekend to work on the homework assignments there. But the third exam is coming up next week. So it's crunch time. And no matter what, by June 29th, we have to finish this course. So I can keep pushing it back, but eventually you may end up with a lot of things due all on the same day. So we don't really have a whole lot of time left, and we'll try to do whatever we can, trying to finish the semester. We'll take a break, and then we will continue with chapter 7. Okay, we'll start. I mean, I understand chapter 7 is not going to be on the exam tomorrow, but it's going to be on the exam next week. So we'll come back and we'll take a brief, short break there and come back and we'll start chapter 7. Two grams, 1.6 grams. That's these two. Okay. So you gotta convert 2 grams into moles. 1.6 grams into moles with molar mass given. Okay. And the molar mass is given. So once you convert them into moles, it's 1 mole. So whichever is a lower number mole is going to be our limiting. Okay. And then the limiting is the one that will determine how many grams of aspirin you're supposed to, how many moles of aspirin you're supposed to get. It's also 1-to-1 ratio. So say if you have 0.5